Deffie-Hellman algorithm by Sadhvi Shishodia, B.Tech Computer Science. What is it? The Diffie-Hellman key agreement protocol was the first practical method for establishing a shared secret over an unsecured communication channel. Also called exponential key exchange, is a method of digital encryption that uses numbers raised to specific powers to produce decryption keys on the basis of components that are never directly transmitted and making the communication more secure. How is this implemented? The two end users, Alice and Bob, while communicating over a channel they know to be private, mutually agree on positive whole numbers P and Q, such that P is a prime number and Q is a generator of P. The generator Q is a number that, when raised to positive whole number powers less than P, never produces the same result for any two such whole numbers. The value of P may be large, but the value of Q is usually small. Once Alice and Bob have agreed on P and Q in private, they choose positive whole number personal keys A and B, both less than the prime number modulus P. Neither user divulges their personal key to anyone. Ideally, they memorize these numbers and do not write them down or store them anywhere. Next, Alice and Bob compute public keys A star and B star based on their personal keys according to the formulas A star equals to Q raised to A mod P and B star equals to Q raised to B mod P. The first diagram shows how the formulas are constructed, and the second diagram explains the logic of the Diffie-Hellman algorithm. The two users can share their public keys A star and B star over a communication medium assumed to be insecure, such as the Internet or a corporate wide area network (WAN). From these public keys, a number X can be generated by either user on the basis of their own personal keys. Alice computes X using the formula X equals to B star raised to A mod P. Bob computes X using the formula X equals to A star raised to B mod P. The value of X turns out to be the same according to either of the two formulas. The personal keys A and B, which are critical in the calculation of X, have not been transmitted over a public medium. Because it is a large and apparently random number, a potential hacker has almost no chance of correctly guessing X, even with the help of a powerful computer to conduct millions of tries. The two users can therefore, in theory, communicate privately over a public medium with an encryption method of their choice using the decryption key X. Limitation of this algorithm. The most serious limitation of Diffie-Hellman in its basic or pure form is the lack of authentication. Communications using Diffie-Hellman all by itself are vulnerable to man-in-the-middle attacks. Ideally, Diffie-Hellman should be used in conjunction with a recognized authentication method such as digital signatures to verify the identities of the users over the public communication medium. Diffie-Hellman is well suited for use in data communication but is less often used for the data stored or archived over long periods of time. Thank you.